What if everything you've ever known, your memories, your planet, your galaxy, was destined to vanish into absolute nothingness? No explosions, no flames, no bang, just a slow, inevitable collapse into the void. This isn't just an idea from a science fiction movie. This is the real fate of our universe. And guess what? It's already started. The process has been ongoing for billions of years, and we're witnessing only the beginning. Every second that ticks away brings us closer to a cosmic conclusion, the end of stars, the end of galaxies, the end of everything as we know it. So how will it all come to pass? Let's take a journey through the timelines of our universe, the beginning, the aging, and the ultimate demise. Get ready. This is no ordinary journey. This is a voyage into the end of everything. Section 1. The Young Universe. It all began 13.8 billion years ago with a moment known as the Big Bang. A single point of infinite density exploded, giving birth to time, space, and everything we've ever known. In an instant, the universe began to expand at a rate faster than the speed of light, carrying with it the seeds of stars, galaxies, and matter itself. The early universe was a furnace of energy, where particles collided at speeds so intense that they formed the building blocks of everything we see today. The first atoms, hydrogen and helium, formed, and eventually stars ignited, illuminating the dark void for the first time. But this was just the beginning. The universe was still young, full of potential, and bound by the laws of physics, laws that would lead to its inevitable aging. Section 2. The Aging Universe. As time marched on, the universe began to cool. Stars, once born in intense firestorms, began to burn out. Galaxies began to drift apart, with their centers becoming more and more isolated. In fact, the universe has been expanding ever since that initial explosion, growing larger and more empty every second. This expansion isn't slowing down either. In fact, it's accelerating. Dark energy, a mysterious force, is driving this expansion faster than we can comprehend. As stars exhaust their nuclear fuel, they die, leaving behind either white dwarfs, neutron stars, or black holes. But in the grand scale of things, even the mightiest of stars are temporary. They'll fade too. The universe's current age is just a snapshot. In a few billion years, the galaxies we see now will be distant memories, and the stars will be nothing but dark, lifeless remnants. The universe will grow quieter, colder, and more empty. Section 3. Death Scenarios. Big Freeze. Let's imagine a future where the universe simply keeps expanding. Stars burn out. Galaxies drift further apart. The lights of the cosmos dim one by one. In this scenario known as the Big Freeze, there's no grand explosion, no violent end. Just a long, slow fade into cold darkness. As the universe stretches, it becomes colder and colder. Even the atoms that make up matter will slowly lose their energy. No heat, no motion. Eventually, the universe will reach a state where all life, all stars, and even the laws of physics are forgotten. This is the ultimate form of entropy, the inevitable decay of everything toward a state of disorder. And it's a fate the universe is doomed to. Big rip. But what if it doesn't end quietly? What if the universe tears itself apart instead? In the Big Rip scenario, dark energy accelerates the expansion of the universe so rapidly that galaxies, stars, planets, even atoms, are pulled apart. Imagine the force of the universe itself stretching, the fabric of space-time being torn, fragment by fragment. Eventually, the very nature of space and time itself becomes distorted. In the end, the universe is ripped apart in a violent, chaotic manner, dissolving into nothingness. Section 4. The Black Hole. Era after the stars burn out and all the other objects in the universe have faded away, the universe will be dominated by one thing: black holes. Black holes are dark, silent giants, massive, invisible, and seemingly eternal. They pull everything within their grasp into their depths, feeding on the very fabric of reality itself. But even black holes aren't forever. Over incredibly long time scales, trillions of years, these black holes will slowly evaporate. This process is called Hawking radiation. It's a slow and gradual process, but eventually, even the darkest corners of the universe will empty. The final remnants of the universe will be small, solitary black holes, their mass reduced to nothing. And when they finally vanish, so too will the last traces of existence in our universe. The entire cosmos will end in a quiet, lonely death. No stars to guide the way, just an endless stretch of nothingness. Section 5. The final moment. At the end, no stars, no galaxies, no matter, no light. Imagine it. A universe